Hello friends, myself Professor Amit Sagar, and in this video tutorial we are going to learn the practical related with the subject embedded and RTOS. Okay, so in this video we are going to learn about implementation of Q in the MuCos 2. Okay, so let us start with our practical regarding this MuCos 2. Now before starting the practical, I would like to give some overview regarding this particular practical. So what is the aim of experiment? So our aim of experiment is to queue implementation for message passing on LPC2148, that is nothing but the ARM7 controller. Okay. So what is a problem statement for this particular experiment is we have to write a program to send a message from task 1 to task 2 using the message queue. If queue is not full, and display the result on HyperTerminal if queue is not empty. Okay, so this is what the problem statement which we have to solve during our experiment session. Okay, so what is the learning objective of this particular is we can do the message queue configuration, we can understand the message queue configuration. Okay, so what is required to perform this particular experiment? So we'll see equipments required. So we may require the trainer kit for LPC2148, that is ARM7 controller, serial cable, power supply, then most importantly your computer with Keel software and FlashMagic software. So our main requirement is we require the Keel Microvision 4 software for developing the code using the MuCos 2 operating system. Let us have an overview about theory part regarding this particular queue. What is queue? We will understand under this particular. A message queue is used to send one or more message to a task. A message queue is basically an array of mailboxes through a service provided by the kernel. A task or an ISR can deposit a message into message queue. Okay, so already we have studied the mailbox service. Now what is the advantage of mailbox service is we can communicate between the two tasks using the mailbox service. Now the limitation for mailbox was we can be able to send only single message or the single string using the mailbox service. Now to overcome that what we can say, the message queue service is actually the extension of mailbox service. Okay, so using using the queue we can send multiple mail or multiple messages from one task to another task. Now basically this queue implementation service is required in order to provide the inter-task communication or inter-ISR communication. We can transmit a message from an ISR to another ISR or from one task to another task. So that is basically the function of this queue implementation. Now whenever we are sending any message on a queue, so that will be sent in the first in first out fashion, right? So whenever you are sending any message, that will be given, that will be sent in a array fashion. Okay, and so the first message will be stored at the last place. Okay, and the last message will be stored at the first place. And whenever you are extracting the message from the queue, then the same FIFO fashion, it will be read from the queue by the FIFO mechanism, that is first in first out. Okay, first in first out. So whatever the message was stored on the queue first, that will be extracted earlier. Okay, so using FIFO and LIFO mechanism, the message will be posted and extracted from the queue array, or that is from the queue. The queue is also called as a array of mailbox. Okay, this is for your kind information, right? Because in mailbox we can send only one message, but in queue we can send multiple messages. That is why we can say the queue is nothing but an array of mailbox. So this is just a simplified definition you can say about this. Now, how this queue service can be used. Okay, so as I said, the queue can be used to send the messages from one task to another task, or we can send the messages from one ISR to another ISR. Now for sending the queue, or for related to the queue creation, we have the different mucos2 commands. So you can see in this diagram, queue create, queue delete, queue flush, then queue post. Okay, like that different mucos2 commands are available. And for receiving the particular queue by the task, the different commands will be like accept command. Pend is for waiting for queue, then query is for related with the error messages. Okay, so just like so here we have different mucos2 commands functions are available in this particular. Now same way, same kind of functions are available for ISR also. So the an ISR can also send the messages using the queue service, but the thing is that it has only 4 mucos2 functions can be accessible, and for receiving only one function is accessible for the ISR. Okay, so this is how the queue mechanism is going to work. Let us start with the coding part of this particular practical, and we will understand by executing the code. Okay, so for that purpose we require Kill Microvision 4 software, and under this particular software we can create mucos2 project. Okay, I have already opened the project for Kill Microvision in the Kill Microvision. Now how to create a project for this mucos2. So for creating project mucos2 in the mucos2, you have to carry out certain step. So here I have directly opened the code file, but you have to go through some series of step. So if I am going through that step, the video will be rather lengthier one. So my suggestion is you go through my prerequisite or first video, that is creating project, creating MuCOS2 project in Kill Microvision 4. Okay, in that all steps are given. Okay, so I'm not going to explain those steps, how to carry out, how to create a MuCOS2 project. So here I'm just making a focus on explaining the code. So let us start with the explaining the code. Okay, so we'll see the code one by one. So first of all, the header file inclusion is there. Then after that, the stack task length, one constant is defined with the value of 100. Then to use the serial communication, we are using initialize init serial for serial communication initialization, and this serial function is defined in different file, but we are using here in the main.c. That's why we are declaring this as a extern. Okay, then after that we are defining the stack for two tasks using the os underscore stk. Okay, so using this MuCOS2 command, we are defining the stack value for two tasks. Okay, we are assigning 100 value for the first task, first stack, and then also we are defining the value of 100 to the second stack. Now very important part, that is os underscore event and then star mq. So here we are creating the event, q event we have created here. Okay, and we have assigned the name mq for the q variable. Then we are for sending the value in the queue, we have created the pointer variable, character pointer variable mq table. Okay, then after that two tasks are defined, task 0 and task 1. Then your main function, integer main. Now under this integer main function, we have called the serial communication initialization, because we are using the serial communication for showing the output of the program. Okay, so then after that, target initialization. Now this target init is basically related with the ARM controller board. So whatever the peripherals are inbuilt in the development board or ARM7 board, so those initialization part is given in this particular target initialization function. Now the very important part, that is, this is MuCOS2 command os init. Okay, so whenever we want to use any MuCOS2 function, before that we must have to use the command os init. Okay, then after that we are creating the queue. Okay, so we have created the queue using osq create. Osq create is a function using which we can create the queue. Okay, then queue table, that is nothing but the pointer for a queue. And then the size of queue we have declared here 20. That means we can maximum 20 mail or 20 messages we can send through the queue. Now after that, we have created the task using os task create. So task 0, name of the task. Okay, then we have given the stack length, that is 100 -1. Okay, so stack length is 100. So here it is pointing to the top of the stack. Okay, this and task stk, it is nothing but the pointer for task pointer for top of the stack for task 0. Then for task 0 the priority number is 3, the numeric value is higher, whereas for task 1 the priority is priority value assigned is 2. It means that the task 1 is having a higher priority. Okay, now the two tasks are created and pointer to those tasks, stack pointer and priority number are assigned in the main function. And then after that, in order to perform the multitasking, we must have to use the OS start. Okay, if you don't give the OS start command, then we cannot perform the this mucos2 cannot run the multitasking. And finally return 0 for coming out of this particular loop. Okay, then the two tasks are defined after the main program. We are going to see one by one. So task 0, in task 0 we have character variable or character pointer variable, characters star rx message. Okay, now this is for receiving the message from the queue. Then after that we have one more variable we have defined, unsigned integer 8-bit, and that name is given ERR. Actually it is abbreviation for the error. Okay, so in order to store, if any error is occurred, then it will be stored in this particular variable. Then after that we have given this function, that is pdata equal to pdata. Why we have given this command? Because during the function declaration we have declared star pdata, but nowhere in the program we are using this particular pdata argument. Okay, we are not passing any argument from one task to another task, and that is the reason we have to give this particular command, that is pdata equal to pdata, so that we can avoid the compiler error. If you don't give this particular statement, then it will give the compilation error like the pdata is declared here but not used, like that. Okay, and then after that in while one function the code is given for the task 0. Okay, so print statement is given, task 0 is waiting. Okay, now this task 0 is actually a receiver task. Okay, so rx message variable, it is for receiving the queue. So for receiving the queue we have the function osqpen. Okay, osqpen, and then the queue variable mq, and if any error is occurred, then it will be stored in the AND error. Okay, so when until the message is received we cannot print the message. Okay, so task 0 will wait until the task 1 is going to send the message. Okay, so we must understand that if so whenever we are saying we are having such command like osqpen. Okay, so pen means it will go in the waiting state till the queue is received or any message is received. If no message is received, it will wait further, or it will wait forever till the message is received. Okay, so next we are going to see the task 1. Again it is having a similar kind of structure, but here this task 1 is basically a transmitting task. Okay, or whatever the messages we have to send, that will be sent by the task 1. Okay, So for that purpose they have declared variable n. Okay, then after that unsigned integer 8-bit error for error message. Then the two string or two messages are declared here using the character array, the tx1 message and tx2 message. So tx1 message is hello t0, then tx2 message is this is message from task 1. Okay, and then to avoid the compiler error we are given p data equal to p data. Okay, now for task 1 the while one loop is given. So what we have done here, so we have printed that first statement is task 1 is executing, then we have posted or we are transmitting the first message. Okay, so what is the first message? Hello t0. Okay, so hello t0 is stored in the tx1 message. Okay, so then the same thing we are transmitting here, and for transmitting the message on the queue we have to use the command osqpost. Okay, and then second message is this is message from t1. Okay, and that is stored in the tx2 message. Okay, and the same message will be sent using the osqpost command. Okay, so this is really how your task is going to send the message. Okay, so let us begin with the execution of this particular code. Okay, so for execution of this code, first thing is you have to build the code. Okay, so to build the code, at the left corner you can see this particular build option, so click on the build. Okay, so as there is no error you can able to see 0 error and 0 warning. Okay, now to see the output I have to click on debug button. Yes, you can see at the middle one, red one. So here I am clicking on the debug button. It is showing me the message evaluation mode running with the code size of 32K. So here I am clicking on OK. Now as we are using the serial communication for we are using the serial terminal to see the output of this particular. So I am just expanding the UART1. Okay, so this is UART1 window. Okay, if you don't see the UART1 window, I will show you how to locate this UART window. So here you can see serial window. Yes, so there is option UART1, UART2, UART3 like that. Okay, so if I click on UART1 it will show me this particular UART1 window. Okay, so now we are running the this particular code. Now when I click on this run button, the two tasks will be running, they will run at a faster rate. Okay, but we have to analyze the output. So that is the reason after running the task I am immediately stopping the execution, and I will show I will explain the execution sequence. Okay, so let us begin. So I click on run button. Okay, here in this UART window you might have observed the messages will be scrolling downwards like that. Okay, so actually this is showing the multitasking execution. Okay, so you can see in the UART1 window what it is showing: task 1 executing. Why task 1 is executing? Because it is having the highest priority. Okay, so then task 0 will be in the waiting state. Okay, so hello t0, it will print hello t0. Task 0 is waiting. Task 0 is waiting. Then this is message from T1. So when the task 0 will receive the message from the task 1, it will be printed here. This is message from T1. Again, after reception of first message, it has the timeout may have occurred. Again the task 0 will go in the waiting state. Okay, again the task 1 executing, then hello T0, again the task 0 will be executed. Okay, and then again the same message will be received from the task 1. This is message from task 1. Okay, so this MuCOS 2 is a multitasking operating system, and using this MuCOS 2 we can send multiple messages from one task to another task. I hope all of you have understand that how we can send the message from one task to another task. Okay, so I have tried to explain from my side. If you have any sort of queries, you can mail me at shirsagar.an, or you can call me at 9527299300. Okay, so I hope from my side I have given a bit effort to create this video. So if you like this video, you can share with your friends. Okay, so thank you very much for your patient listening.